That diamond on your finger? It started 100 miles underground, in complete darkness, under pressure that could crush a car, at temperatures hot enough to melt steel. I'm Doctor, and today on How We Made, I'm taking you on a journey to one of the most extreme environments on Earth, where diamonds are born. And trust me, this story is under a lot of pressure.
First, let's destroy a popular myth. Diamonds do not come from coal. I know, everyone says diamonds are just coal under pressure, but that's completely wrong. Here's why. Coal formed from dead plants about 300 million years ago, but most diamonds, they're 1 to 3 billion years old. Diamonds existed on Earth before plants even evolved, so coal and diamonds aren't even related. Both are made of carbon, yes, but they have completely different origins. Coal forms near the surface from organic material. Diamonds form deep underground from pure carbon under extreme conditions. Totally different processes. So if diamonds aren't from coal, what are they from? Let me give you the recipe for making a diamond. Ingredient 1, carbon, pure carbon. Not from dead plants, but carbon that's been in Earth's mantle since the planet formed. Ingredient 2, extreme depth. We're talking 90 to 150 miles below your feet. That's in Earth's mantle. Way deeper than any mine, any drill. Ingredient 3, insane heat. At that depth, temperatures reach 900 to 1300 degrees Celsius. That's 1650 to 2400 degrees Fahrenheit. Hot enough to melt most rocks. Ingredient 4, crushing pressure. We're talking about 725,000 pounds per square inch. Under these conditions, magical happens to carbon atoms. Here's where the science gets cool. At normal surface conditions, carbon atoms arrange themselves into graphite, the soft stuff in your pencil. The atoms form flat layers that slide past each other easily. That's why graphite is soft and slippery. But deep underground, under all that heat and pressure, carbon atoms are forced into a completely different arrangement. Each carbon atom bonds to 4 other carbon atoms in a 3-dimensional tetrahedral pattern. This creates an incredibly strong structure, a rigid network extending in all directions, like the difference between a pile of papers and a solid concrete block. The atomic arrangement is what makes diamond the hardest natural material on Earth. This transformation happens atom by atom, molecule by molecule. The carbon atoms lock into place, forming a crystal structure. And slowly, over time, maybe days, maybe weeks, maybe millions of years, a diamond crystal grows. Here's something fascinating. Scientists don't actually know exactly how long it takes to grow a diamond. Some diamonds might form in just days or weeks. Others grow over millions of years. And diamond growth isn't continuous. Most diamonds found today are incredibly ancient. We're talking 1 to 3 billion years old. That means the diamond in your engagement ring is older than the dinosaurs, older than complex life on Earth, older than oxygen in our atmosphere. To stay a diamond, it needs to stay deep underground where the pressure and temperature are right. If it gets too close to the surface too slowly, it'll convert back into graphite. Diamonds are unstable at surface conditions. Diamonds form 100 miles underground, but volcanic explosions bring them to the surface. Incredibly rare, violent kimberlite eruptions. Deep beneath the surface, molten rock called magma builds up enormous pressure.
When this magma finally erupts, it explodes upward, traveling from 100 miles deep to the surface in just hours.
The magma creates a vertical pipe called a kimberlite pipe as it blasts its way up, and it carries diamond-bearing rocks along for the ride. This rapid journey is critical. If the diamonds travel too slowly, they'd heat up and convert to graphite. These kimberlite eruptions haven't happened in recent human history. The most recent ones occurred tens of millions of years ago, when Earth was hotter and more geologically active. The kimberlite pipes they created are now solidified volcanic vents that go straight down into the Earth. Famous diamond mining locations like in South Africa, Russia, Canada, and Australia are all ancient kimberlite pipes. Miners find these pipes at the surface, then dig down following the pipe deeper into the Earth. The deeper you go in a kimberlite pipe, the more diamonds you typically find, because you're getting closer to the source. But not every kimberlite pipe contains diamonds. Most don't have enough to make mining worthwhile. Finding a diamond-rich pipe is incredibly rare.
When diamonds first come out of the ground, they don't look like the sparkling gems you see in jewelry stores. They're rough, dull, and covered in rock. It takes a trained expert to even recognize a rough diamond.
Then comes cutting and polishing. Diamond can only be cut by diamond because nothing else is hard enough. Specialized tools with diamond edges are used to shape the rough stone. Master cutters study each rough diamond carefully. The cutting process reveals the diamond's true beauty, its ability to refract light into rainbow colors and sparkle brilliantly. This optical property, combined with hardness, is what makes diamonds so prized. Not all diamonds are clear. Tiny amounts of other elements create colors. Nitrogen makes yellow, boron makes blue, radiation makes green, and pressure makes pink. So there you have it. Diamonds aren't coal under pressure. They're pure carbon crystallized 100 miles underground, over billions of years, at temperatures that would vaporize you and pressures that would crush you flat. Then blasted to the surface by ancient volcanic eruptions, carved out of solid rock, cut by experts in fiery diamonds and epic journey from Earth's most extreme environment to your jewelry box.
Pretty incredible story for a sparkly rock. On Doctor, that's how he made. If you learned something amazing today, hit that like button. Subscribe for more origin stories. Comment below, what should I explain next? See you soon.